ladies and gentlemen, mainly gentlemen, what I can see here. I would like to do a quick poll just to get a bit of a feel of the crowd. Who of you has a technical background, engineering background? Okay. That's bad news for me because I don't. And I always find it a little bit intimidating presenting in front of critical engineers. But anyhow, I'll try to do my best. Actually, I'm filling in for my colleague Eric, who's also our CEO. He's actually originally meant to be here, but he, due to a family obligation, has to be in Shanghai today. Therefore, I'm trying to do my best to fill his shoes. This presentation indeed is primarily about discrete manufacturing, but obviously a lot of the things that you will see are also applicable in other areas as well. And it basically draws from a white paper that was published by the Smart Factory Task Group of the IIC. So a lot of the things that you see here, you might find back in the white paper, which I would strongly encourage to also have a look at. The final version was actually published in end of February 2017, so it's quite up to date. I have two objectives for the presentation today. One is to summarize the current state of the discussion regarding industrial IoT implementations in discrete manufacturing environment. And the second is to present three representative test beds which are at different levels of maturity and also covering different areas and planes of the industrial IoT architecture framework. And last but not least, the one thing that I would like to achieve today is to make a plea for actually expanding testbeds and to adopt more testbeds, because we believe it's a great tool to advance the adoption of industrial IoT. Yeah, a quick introduction regarding who we are and what we do. I work for a company called IoT ONE. IoT ONE, we are based in Shanghai with our headquarters and have some representatives around the globe, mainly in the US and also in Germany, where we believe most of the magic happens. And what do? We provide go-to-market solutions for industrial IoT solutions, both online and in China also offline. So basically what we do is we provide offering planning, content creation, campaign execution, and channel development. Globally, online, and in China in particular, we also have boots on the ground to provide multi-channel support for events, offline lead generation, innovation centers, as well as sales ramp-up support. Yeah, I think I don't need to introduce the IIC. I think most of you are very familiar with it. What I briefly would like to introduce is the Smart Factory Task Group. The Smart Factory Task Group is one of the official task groups of the IIC, and any member can participate in this. At the moment, these are around 60 members in the task group that meet mainly online in bi-weekly meetings done via Cisco WebEx, so everybody globally can actually participate. And they work on white papers. This was the initial focus and will continue to be a focus of the task group, but they also want to move forward into providing what they call executive summaries, so more practical insights and strongly summarized and distilled to make those available. And a second white paper is currently actually being published around green patch projects. For the ones that don't know what green patch projects are, is basically it's putting state-of-the-art production lines into a brownfield setting. So light tower type of projects within a brownfield setting. Yeah, I would like to briefly set the context regarding smart factory within a discrete manufacturing environment. So we have conducted a meta study around surveys done around the topic of IoT adoption within an industrial space. And what we can clearly see is that the results are very inconclusive. So we have also done an own survey in China on top of that to get a bit of a feel. So some surveys suggest already a more advanced adoption of industrial IoT, whereas others are a little bit more pessimistic. And we are probably part of that second group where we are already a little bit more pessimistic with regard to the existing adoption. And in China, we clearly see this. So you see us here all of the way at the right. So almost 60 to 70% have not yet started planning even any industrial IoT adoption in China. That is, the other surveys were apply globally. So I think one survey suggests actually that there's already a 50% adoption. We are pessimistic about this, so it's also rather a question, what do you consider an industrial IoT adoption? And yeah, most companies or most surveys actually put it into the area of that companies are currently planning. I think it's easy to say, but is it real planning or is it actual talking around industrial IoT adoption of companies? I think this most people are probably familiar with. It's the industrial IoT architecture framework of the IIC. This is actually for us the probably most important visual to guide our work, and I can strongly encourage for the ones that are not yet familiar with it. It is really practical and has been super useful for us in our work. And today we are going to introduce 3 test beds. One is in the area of interoperability, which is about time-sensitive network testbed. And I see actually some of the companies that have been involved with this also present here, which is great. And then the second one is in the area of edge aggregation and device management, which is the track and trace testbed. And last but not least, probably the most highest level, but probably also least mature in terms of development, is the testbed on smart factory web around business systems and applications and integration. Why do we look at those different areas? Because we believe it's important to look at all the layers to see, also get a little bit of a feel of where's the pace and the level of discussion at the moment, and also where are the bottlenecks. For instance, one key issue that we see is definitely still interoperability. So interoperability is still one of the main bottlenecks that we see for more advanced IoT adoption to actually take place. So a brief value analysis in terms of IoT, because whenever you make a decision around IoT, I think the business case needs to be sound. Therefore, we have looked at this McKinsey study done in late 2015, which we still believe is highly suitable also to the current environment, as well as looking at the future. Is the value allocation for IoT projects and IoT offerings, and looking at where's the value generated and the revenue generated. And what you can clearly see is that as compared to past scenarios, the value is mainly created in the areas around system integration, software app, and software infrastructure. So you can assume that the hardware part is more and more reducing in terms of value creation. This also, as a consequence, means that a lot of the companies that have traditionally been more in the hardware space obviously are now investing heavily into other disciplines, into crossing those fields, into combining things, and also looking at areas of software, system integration, and service. I think this is probably quite intuitive for most people to see like that the value is more and more generated in the software side of things and the system integration, but I think looking at the real numbers is quite, I feel quite a challenge, or is putting a question mark around a lot of the business strategies that you see in place for a lot of the hardware providers. Now, what are the general adoption drivers? So I think it's clear that IoT is getting good momentum. But there are a lot of skeptics, actually, that say a lot of the technology existed already 10 years ago, or maybe even longer. All this is true, and probably most of the technology has already existed. But we see a clear convergence, which is currently driving this adoption in the discrete manufacturing space, at least. So we call it supporting factors, and those are around the themes of customer expectations. I mean, just selecting one of them, rapid time to market. So we see that fast development, particularly in markets like China, for instance, where I am based, is extremely important. Then also the increased need for productivity improvements, market readiness of several key facilitating new technologies, example being machine learning, and then of course also rapidly falling costs of mature technologies in areas, for instance, like sensor technologies. So while a lot of skeptics argue that the technology was already available, we believe that the timing right now in terms of convergence of a lot of factors is actually the key driver that is clearly pushing the momentum right now. Now, in terms of benefits sought by most discrete manufacturing companies or companies in the whether technology providers for discrete manufacturing end users, or as well as companies that actually seeking applications within their own operations environment, is mainly focused still at the moment and in the short and midterm from what we can see. So the most mainstream applications focus around operations efficiency and operations intelligence, whereas in the long term the shift should be and hopefully will be, and we can already see some clear indications into new business models and new revenue generators. And for the first part, operations, efficiency, and intelligence, we're looking at 2 test beds that are focused around that area. And then for the new business models, we're looking at the 3rd test bed of the Smart Factory Web test bed. And now this is actually the transition towards the test beds and why test beds are so important actually. So it's given sort of an argument. So clearly, operating technology and IT in the area of industrial IoT is converging. And in the past, there were limited interfaces between IT and OT, and this interchange becomes stronger with both the value, the benefits, as well as the challenges that come along. But in order to reap the benefits of industrial IoT, those strings actually do need to be stronger, both organizationally speaking as well as technologically speaking. And we fundamentally see 3 ways to create that connectivity in terms of data interfaces, what we call shop floor to top floor connectivity, which is fundamentally the essence of industrial IoT. And those 3 connecting areas are already broadly used. What we cannot clearly define is which ones are going to be dominant and which ones are going to have more usage. So at the moment, all 3 are broadly used, but not clear which ones will eventually be dominant. So one is the direct communication. So when the sensors and actuators are equipped or maybe even post-equipped with communication modules and then communicate. An operating technology upgrade. An example, for instance, when the PLC or the industrial PC is reprogrammed to deliver all the data to the IT system. And then last but not least is the gateway aggregator, the sort of the control loop. For example, the I/O module is connected with a gateway. What we believe is interesting to observe is the development for the gateway aggregators, because even from what I heard, I just arrived today at the Hannover Fair, so I'm not sure whether that still happens. I hope this is not secret information still. But Dell is, for instance, partnering with Linux to launch what they call the Fuse program, which is a play on the gateway aggregator, and to build an alliance around that and strengthening that communication approach. Now let's dive into the test beds, and I will also briefly describe what test beds actually are and also what they are not in comparison to other concepts in the adoption of IoT. So typically, when you look at an IoT project, we structure this roughly into those 3 phases, so planning, execution, improvement. I think there are a lot of other models out there, so but it's just structuring the approach a little bit. And we have highlighted in red the areas where the main challenges are. And it starts already in the value understanding. So whenever you define a strategy, obviously understanding the value is the potential value generated is going to be very important. With IoT projects, this is more challenging than it would have been in the past, for instance, with more conventional IT or operating technology projects. Also, what we can see is that when it comes to solution architecture, technology selection, and vendor selections, most discrete manufacturing end users are outside their comfort zone, let's say. And they typically have to rely very strongly on external vendors, either the technology vendors themselves or also external independent advisors to support them in that approach, which is different to how they might have approached IT or OT projects in the past. And the implication, obviously, for those technology vendors is that they need to build this advising capability in terms of making the business case, as well as helping the end users, so in the discrete manufacturing space, to actually make those critical choices. And then the third element that we see is very different, is in the area of business process upgrade and talent upgrade. I focus on business process upgrade, and we have this beautiful example in China. I'm not sure how many of you do business with China. Show of hands. Yeah, quite some. In China, the classical model is that companies buy what we call the robot statue. So it's a robot that you have in your factory for delegations that visit the plant, and then you turn it on, and then after they leave, you pretty much turn it off. And this is a clear indication that companies find it challenging to actually create those cross-disciplinary teams, but also the understanding in terms of how to reap the process benefits of IoT solutions. And robots is just here an example. It can be any sort of high-tech equipment that they're using along the way. Yeah, then last but not least, in terms of improvement, if I look at it from a discrete manufacturing standpoint, the key issue is legacy investment. So having invested in capital equipment that is actually not flexible, like a Tesla, for instance, to adjust due to or through system upgrades and software upgrades. And this is something that we also see, of course, particularly within a discrete manufacturing environment, is to create hardware that is adoptable and agile in terms of how you can, in the future, also upgrade it along the way. And there are probably a lot more challenges, but we have narrowed it down to those four. Now, let's talk a little bit about what are testbeds. The purpose of a testbed is to learn. Versus we put here four concepts. One is what we call the lab, then the testbed, the pilot, and a project. And the testbed typically involves several parties by definition. So several vendors, several technology providers, an end user, and so forth. And the objective is to learn about the strategy around how to use the technology, and also to learn more about the specific use case and how to adopt the use case. Yeah, and if you look at pilots, it's very often mixed up. Pilots are typically more focused within a company to launch, to work with a more mature technology, but with a new market entry to test sort of a test of concept for a new type of application. And yeah, I think this is fundamentally what a testbed is. Now, when we look at the discrete manufacturing space, we have those within the IIC, those 9 testbeds that we have identified as the most impactful testbeds. Number 1 is the time-sensitive network testbed that we're going to introduce. Then the second one is the track and trace testbed, and then smart factory web testbeds. And we have selected those because they are at a different level of maturity, are in a different layer of the IoT, industrial IoT architecture framework. And then you'll also find other testbeds here. The IIC website is really beautiful to dive deeper. And typically, when you look at the testbeds, you have a good chance to actually go to a dedicated website, either from the key vendor that is setting up the testbed, or from even independent organizations, like, for instance, for the smart factory web testbed, which has a super website to actually see the use case in live playout. Now, the first testbed is time-sensitive networking. So I'm not going to go very deep in terms of the technical challenges here, but I want to give sort of a flavor what is the idea and what is the rationale behind the testbed. I would like to highlight that this testbed actually also won the IIC Testbed Award in 2016. So it's really, if you were selecting one testbed to look at, I would highly recommend to look at this. And why is this? Because it addresses a very fundamental technology which is sort of the bottleneck technology for a lot of the other use cases in the future to evolve. So what are time-sensitive networks? Basically here it's focusing on a solution to enhance production automation. And the goal of this time-sensitive network is to achieve real-time control and synchronization of high-performance machines over a standard Ethernet protocol. So a lot of the past, so the key challenge being two. One is that the Ethernet protocols are not suitable for time-sensitive, so past Ethernet protocols are not suitable for time-sensitive applications, as well as there's a lot of standards out there, so interoperability is an issue. And I think my previous speaker was from the OPC UA, so therefore he will have introduced a lot on this already. So you will see that, and I think the OPC is also present here, which is the organization, for the ones that don't know it, is the organization that is basically driving this Ethernet protocol. So the companies being involved here, you can see here the actual physical testbed is, there's two locations, one in Germany and the first one was in Texas from National Instruments. There's a beautiful video also online where you can explore this and really see it working live and how it actually operates. So it addresses basically three areas. One is time synchronization, and the other one is the traffic scheduling as well as system configuration. So basically what we mean with system configuration is a centralized update mechanism without having to go into every machine, every independent machine separately. So yeah, the benefits are obvious. I mean, if you are able to centrally control with an Ethernet standard that is reliable and has this capability of time synchronization, also the update capability and all sorts, it basically allows you to centrally control the whole process. It provides real-time system access, and you can do real-time software updates, which are not as time-consuming. Therefore, also downtimes are less. There's a real-time data transfer that is scalable, and you can actually hook up suppliers and vendors using a unique or a standardized protocol. This is testbed number one. Now, testbed number two is actually, from what I remember and understand, one of the first testbeds to be kicked off. And probably technologically speaking, it's one of the most basics. And most skeptics would argue that a lot of the technology here was already available 10 years ago. And this is, I think, a beautiful example that shows that the convergence right now is actually where the innovation happens and not within the individual technological silos. What is the fundamental use case? So the location is actually one of the Boeing facilities, where it's basically about tracking tools, key equipment in the process, and they have had two phases. One was for drills, the other one is for forklifts. So forklift was the second phase. As an example, I focus right now on tools. So basically, when you screw together an airplane, it's critical to know where your tools have gone, as well as which torque level you have actually applied for the drill application. So different applications require different torque strengths. So it's a major product safety issue. And as you can imagine, in an airplane, not unimportant to do this. And for the forklifts, it's also has different reasons why it's actually being used, but the use case is not dissimilar to the tools. So general background information, maybe it's to create real-time visibility into the logistics routes, both for the logistics and production routes, and also the material flow, and to increase the efficiency as well as the effectiveness of the key tools used in the process. And summarizing here again, all of these technologies were fundamentally already available 10 years ago, but now at the convergence of it, it's actually where we find feasible, also from a business case standpoint and an investment standpoint, a feasible and good return of investment type of use case. In the interest of time, I understand I have five more minutes to actually conclude the presentation. A quick introduction of the Smart Factory web testbed, which is probably the youngest testbed and the least mature because it builds on, it's basically a very high level IoT application where it's already about a new business model. Is the fundamental objective is to build a network of smart factories, and you will find those right now in the testbed in Korea as well as in Germany, and it's led by the Fraunhofer, this project, as well as this testbed, as well as the KETI, which is the Korean Electronics Technology Institute, so sort of the Fraunhofer counterpart in Korea. And yeah, a use case could be, for instance, eventually that a company, that a factory receives an order, but is running at capacity, cannot accept the order, but instead of just saying no to the customer and reverting the order, the factory A can actually look into the smart factory web and find a company or factory that has the capabilities as well as the capacity to actually complete the order. And then the whole back-end processes that are required to actually complete this satisfactorily for the customer. This is how you have to imagine the stack in the back end. So basically it starts at the edge tier. We discussed the edge tier already, right? So we discussed OPC UA, so basically standards, and there you can actually see what we mean with bottlenecks. So if this doesn't work, all the rest doesn't work fundamentally. Then you have the platform tier as well as the enterprise tier. So the enterprise tier is basically the end user accessing it, where he or she makes the transaction, whereas the platform tier is basically the apps and the software that is running in the backend, as well as the database management system. Now, this application could be both a new business model in terms of offering this as a service, so the factory as a service, but it also gives large organizations, large manufacturing organizations, ways to manage their own operations and supply chain footprint, obviously. So it's not just a new business model to offer as a service, but can also be a model to help companies to actually organize their own global manufacturing footprint and supply chain. So also key standards here being used. I mentioned OPC UA, the Ethernet standard, as well as automation ML is used to describe the plant engineering information, such as equipment characteristics, interfaces, and capabilities. So automation ML, for instance, as a standard, is critical to basically define the capabilities of the different factories in the smart factory web. This is, as said, concludes the testbed examples. As said, you can dive much deeper into the specifics, also in the technical specifics online with the IIC. Again, I can encourage to visit the IIC website for more information. I would like to conclude, to give a little bit of a concluding argument for testbeds, so that you go home, hopefully, with the impression that testbeds are a good tool to actually advance the adoption of industrial IoT. So this is mixed up. Okay, so basically, what are the key bottlenecks? So I want to now look at the critical side. Initially, I looked more at the positive arguments. Now I want to look a little bit at the critical arguments or the challenges as well. I mean, there's mainly three challenges that we see discussed in the discrete manufacturing environment. One is obviously cybersecurity, and then the second one is uncertain return on investment. So as I mentioned earlier, to understand where and how the value is generated to industrial IoT projects, which is much less certain than with a traditional operating technology or a traditional IT project that you might have implemented in the past. And then the lack of standardization, in particularly at the edge layer. I think OPC UA again I mentioned, and other standards that are currently hopefully getting more traction in the market. So basically, if you look at it in terms of convergence of the IT, so the information technology and operating technology into industrial Internet of Things applications, the challenges as well as the benefits obviously merge as well. And here we can look at the challenges that are brought in from an IT perspective as well as from an OT perspective. And then looking at it from a business standpoint, so how are decisions made and how are budgets actually defined? We have done a survey on this in 2016, and basically what we found is that typically the leadership of IoT projects lies within IT or a specific strategic department, or what we would say in German, a Stabsstelle that is mandated to lead the project. And the budget very often is derived from operations, R&D, and engineering, whereas the end users is then maintenance, is maintenance and operations, and obviously the oversight and control for this is in finance. Why do we highlight this? Because most OT and IT projects are much more straightforward when it comes to making a decision around defining the deliverables as well as defining the budgets for a project. So here the key is actually getting all the decision makers and stakeholders actually integrated in the process, and add even those vendors that you need, for instance, for the technology selection, key technology selection, system integration, whatever is required, and getting them on board early on in order to define the strategy. And then last but not least, it's a beautiful discussion around data. So if we look at the three test beds, at the end of the day, all the three test beds are around data. And it's clear that the value generation is moving towards the data, and the key question for most companies in the discrete manufacturing space, whether they offer technology for the discrete manufacturing space or whether they are end users in the discrete manufacturing space, is around how to generate actually and reap that value. And yeah, obviously along the way, platforms are squeezing in here. So for instance, the factory as a web was one example of such a platform that could eventually be in between and reaping the benefits. But that being said, I think a lot of the discussion is around who sells the data eventually in a meaningful way through a platform. But at the end of the day, that's not only where the value is generated, and I think that's particularly important for discrete manufacturing end users, is that it's also about the ownership of that data originally. And we like to use the example of oil. So both the oil extractor around the world has a benefit on owning the oil, but also the refineries. So all the oil and gas companies actually refine the products, obviously generate value along the way. And for most companies, the question is, where do you want to be in that puzzle? Whether you want to own the data and make a business case out of that, or whether you want to be the refinery and basically process that data to make it useful to decision makers. That basically concludes the discussion or concludes the presentation for today. I think it was a quick walkthrough through the discussion case of discrete manufacturing. There was a lot happening already in the last couple of days, so I hope I could add a little bit of value in that discussion. And yeah, I'm also open for questions, but I think we're already behind schedule a little bit.